Well, good morning. May you live in interesting times. A Chinese curse. This motto appears on the call for papers for this conference, and I really like that because there is a certain tension in it. It is a good wish, but at the same time it is categorized as a curse. And I think that the main subject of our conference here, which is digitization, and Industry 4.0 is part of this digitization, is something where this tension is also there. At the end of the day, we will only see whether digitization and everything which it implies will really be something which is a blessing or which will probably be a curse. I'm very happy to be here, and I would like to thank Jacques Fauré and his organizing committee for inviting me to come to beautiful Cape Town and to Stellenbosch and to talk to you about Industry 4.0 chances and challenges of the ongoing digitalization. We all know that the internet is a ubiquitous, everywhere existing thing with some 20 to 50 billion endpoints, IoT sensors, and so on. And these sensors are producing an amount of data more than 44 zettabytes, which is really an awesome figure with 21 zeros behind it. So we are probably not really used in the daily usage of this high numbers. The Internet of Things is gaining momentum, and I think cartoons very often show what the real trend is. For instance, in 1984, one generation ago, parenting would be something like saying, did you really brush your teeth or did you just wet the bristles to make it seem you did? That same father would say today, did you really brush your teeth or did you just hack your toothbrush to make it seem like you did? This really shows into which degree the Internet of Things is really entering even our private life already. The outline of my presentation after this short introduction will be, I'll talk a little bit about the features of Industry 4.0, then go to the reference architecture model of this industry, look beyond the hype a little bit, take then the road a little bit, opening it more to the economic dimensions, not only focusing on manufacturing as in the first 3 chapters, and then end up with some ethical considerations. Internet of Things and Services, as you can see here, we will, for the next few minutes, then focus on what is the smart factory, the smart devices, and Industry 4.0. This is the German spelling, which I have just written down here. Industry or products are something which man has been providing from the very first existence of man. So that's a very, very long history. And I think even if we go back to ancient times, technology, factory, and the product itself were the main issues in production, together with the commercial side, the commercial processes. And if you take the lifetime of, or the life cycle of these things today, we have developed, particularly in the last maybe 30 years or so, some very powerful digital management tools, like the product data management, the supply chain management, the manufacturing execution systems, the product lifecycle, the application lifecycle, and all these things. I'm putting that back to your remembrance or to your mind to point out that Industry 4.0 is nothing which started from scratch. That really is something which is building on existing things, existing technologies. The modern industrial trends today, I would think, is automation, simplification, virtualization, customization, and servitization. Servitization probably being a rather new word, meaning that not only the product is important, but also the service or the usage of this product is quite important. Next to these trends, we have 8 main value drivers, those things which really determine the cost and the cost effectiveness of what is being produced. It is quality, it is labor, it is time to market, it is the asset utilizations, the resources, the inventories, the supply-demand match, and finally the service and after-sales things. All these 8 levers do have some subfields, and my list here is by no means complete. I only took one example for each of these levers to write it down here. And people from McKinsey tried very hard to analyze all these different levers which are there in order to find out what Industry 4.0 application could finally really bring in terms of cost savings. And you see that in all these fields, cost is going down, productivity is going up, time is shortened, inventories are closer, forecasting is more accurate, and if you take all that together, one can say more or less that Industry 4.0 helps in efficiency putting up about 20% or so. 20% efficiency putting up is really a huge amount of money. It would go in the zettabyte area, if you like, with the 21 zeros. It's really a big effort, and therefore people are interested in doing that. Industry 4.0 focuses on the end-to-end digitization of all the assets and the integration of the ecosystem with all the value chain partners. And there are 4 constituents in this Industry 4.0 basic philosophy. It is the horizontal and the vertical integration. It is the consistent engineering, and it is the consistent usage of the digitalization technologies. All these 4 issues will be looked at in the next 4 slides. The horizontal integration means mainly that in addition to the company internal process from purchasing to logistics over the manufacturing, also now includes the networking to cooperation partners, to suppliers on the one side, and to the customers on the other side. So it is really a comprehensive horizontal integration which we are observing now. The vertical integration, there the buzzword, the real important thing is the interoperability. Interoperability of machines, devices, sensors, and people that connect and communicate with each other. And all that communication is done in real time. That's also very important, which allows self-learning and self-controlling systems to react immediately on changes. It allows predictive maintenance, guessing when the machine will break down in the usage area of the customer, and also enables an individualized production. The consistent engineering mainly is expressed by contextualizing all available information, the sensor data, in a virtual digital representation, a copy if you like, or even better, a digital twin, which is being done. So you have the real asset, whatever is being produced, a car or whatever, and you have the digital image of that on your computer, the modeling, and you can very easily calculate what would be the next step and then reflect that back to production. And you have this strong interaction between the two. And this requires that this, this point, oops, oh, I didn't, sorry, requires that this linking between the real product and the digital copy, the linking between the computer world and the real factory world should really work without any misunderstandings. And the word for that, which is used, is we need a semantic kind of cooperation and interaction and communication. Finally, the technologies which we need in the Industry 4.0 environment can be clustered into four sectors. One is the data, the computational power, and the connectivity. That is the big data, the cloud technology, the machine-to-machine interoperability, blockchain technologies, if you like, and all these computational areas. The analytics and intelligence cluster contains the analytics, contains the advantage in artificial intelligence and machine learning, and it also includes the advanced algorithms which we have to develop. Then digital to physical conversion, that is the area of the smart sensors, the additive manufacturing, and also the energy storage and harvesting, things like that, because with this myriads of sensors, you do have that problem of getting energy to all these different sensors which have to react. And finally, the human-machine interaction as the fourth cluster, where you have virtual and augmented reality, human-robot collaboration, and things like that. So these are the four fields where we really have to put our engineering attention to. Now, the reference architecture model. This model, RAMI, Reference Architecture Model for Industry 4.0, is a three-dimensional map to approach this industry idea in a structured way. It ensures that all participants understand each other. It combines all elements in a layer model. We'll see this layer model just in a minute. It splits the complex processes into manageable parts. It takes into account existing methods and standards and is rooted on the ISO OSI reference models, mainly taken, by the way, from the electrical engineering, where we have the smart grid architecture model, which is being used for our electrical equipment design in the world right now. The three axes which are in this model here, in this architecture model, I will try now to understand, to explain these different axes. This is the first axis here. It relies or is inspired by the famous automation pyramid, which is, by the way, a child of Industry 3.0, and you are all known about that. That starts with the level of the production data. Then you have the second level, which is here, which is the data providing layer, data acquisition layer. Then we have the SCADA that gathers information. And then we have this information being changed to knowledge in a way, in a data analysis and system level. And then finally, it enables action here in this pyramid of thoughts. This is basically still concerned in Industry 4.0, but there are some changes, and the next slide shows these changes. For instance, we have the roles distributed in a network, so it's no longer a hierarchical system. We have all participants interconnected even across the hierarchy levels, which was not possible in the former Industry 3.0 automation pyramid. And the product itself, as well as the outside world, the customers, the suppliers, and so on, as I have already indicated, are part of this smart network in Industry 4.0. Second axis for the three-dimensional is this layered information technology structure, starting with the asset, the real thing in the physical world, the transition from physical to digital in the integration layer, the standardization of the communication in the communication layer, the event processing, describing of execution rules and things like that in the information layer, then the formal description, the formal integration in the functional layer, and finally, on top, the business layer, the organization of the business processes. And the third axis, as you see here, is the product life cycle from the first idea down to the scrapyard. And that, again, is then differentiated between a type, which is more the developmental part, the blueprint part of it, if you like, and the instance describing the real product with a serial number, with data, and so on and so forth. So with these three axes, we have this complete picture of the architecture of Industry 4.0 with the production stages, as you see here, with the life cycle stages, as you see here, and with these 6 information technology layers where you have all the information necessary available in that model. Industry 4.0 is something dealing with connectedness. Connectedness in the sense that, for instance, you have a connection between the working level and the top level here, which is the shop to top floor combination. Or you have the machine-to-machine interconnectivity, which is the autonomous machine idea. Or you have this outside consumer or supplier communication, which is possible. And you also have, for your machine level, for the asset level down here, the service provider or the quality operators going via the cloud, directly interacting with what is necessary there. The communication between the office floor, the top floor, and the shop, the organizational technologies and the informational technologies, that was quite a, or is quite a challenge for software developers, because OT is something being done in real time. And IT is not necessarily real time. And to fit these two worlds together, if you like, that was one of the big challenges. Then the workpiece as a data carrier to determine the next manufacturing step. The smart product communicates with the machine. This is going on in this level here on the shop floor level. And altogether, these features, communication features, are the interconnectivity which are flawlessly interpretable, which require flawlessly interpretable semantics, as I have already mentioned before. The interconnectivity requires that we have standardized communication protocols. We have the standardized semantic language, for instance, the web ontology language, OWL, and naturally that has to be easily installed. Who translates now between these different elements on the shop floor level, for instance, from machine to machine? It is the administration shell. The administration shell is the data store for all information about the asset, is the standardized communication interface to the network, and is the virtual image of the physical asset describing all its properties. Now, coming back to semantics, that's something which I always find that people have difficulties in really understanding, and I deliberately took here an example from literature, not from engineering literature, but from literature. Tolkien, The Hobbit, he has one scene there, there's this guy Bilbo, and the other is Gandalf, and Bilbo says, "Good morning." And Bilbo asks, or Gandalf asks, "What do you mean? Do you wish me a good morning? Or mean that it is a good morning whether I want it or not? Or that you feel good this morning? Or that is a morning to be good on?" Now imagine if you had a production process and the receiving part would have this signal and try to understand what really was meant by this incoming signal. And therefore, you need really a very clear protocol, a very clear understanding, a semantic understanding on both sides in order to be in order to make possible production things. The Industry 4.0 component consists of the administration shell plus the asset. The asset is the real life share, is the real share, whereas the administration shell is the digital share providing the status plus lifecycle data. And that can, in a way, be equated to what I have introduced already to you as the digital twin. So the digital twin idea is really basic to Industry 4.0. The whole thing, as I've explained right now, was developed in Germany in 2011, first time put to the stage. And then it spread over to Europe. You see these many countries here. The European Union is aligning the national plans, and it spread also worldwide. In the United States, we have the Industrial Internet Consortium. In China, we have Made in China 2035. We have it in Japan. We have it even in Australia. They recently joined the Internet Things Alliance. All they are trying to develop their own architectures with some features, but the architectures have all to be compatible with each other so that the global compatibility is really guaranteed. Japan is taking a very interesting own way because in contrast to what we have normally, the first, the second, the third industrial revolution with the steam engine, the electrical power, the automation and computer down to the fourth one with artificial intelligence and IoT, the Japanese were thinking about societal developments. They start with the primitive society, the agricultural society, the industrial society, the digital society, and then the human-centric and solution-oriented ultra-smart society 5.0, which they imagine as something being far beyond industry in the narrow sense. It represents a state that appears almost utopian, a perfectly connected, highly efficient and inclusive society which fully integrates the cyber and the physical worlds, making use of all these technologies, IoT, robotics, AI, and so on and so forth. We'll see how that larger approach will really live in industrial environment. Industry 4.0 beyond the hype. A number of management consulting firms are continually monitoring what is going on as Industry 4.0 in industrial environments. In 2016, 2 years ago, 85% of the companies assumed that they will have Industry 4.0 as a routine in 2020. More than half of them is expecting the increase in productivity, which I said would be something in the order of 20%. And 60% say they want to lead in setting the agenda. But in reality, at least 2 years ago, we had only 22% of the companies having implemented measures designed to realize the potential, and 85% didn't regard themselves as leaders in digitization, but more or less as laggards. Now, more recent data from the German mechanical engineering, the answer to the question, in which new technologies in manufacturing production engineering do you plan to invest in this year, in 2018? We have good answers, convincing answers, more than 50% in big data, in IoT, and in robotics. But we have less convincing answers in the field of AI, artificial intelligence, and the digital twins, which, as you know, are essentials for Industry 4.0. So there is a slight problem there. Again, executives from German enterprises now, not only in the mechanical engineering field, but overall, which innovative technologies are you currently using or planning to use in your enterprise in the near future? Good answers for smart devices, IoT, cloud computing, all these modern things, yes. But Industry 4.0 and artificial intelligence are still quite low. So one thing is sure, Industry 4.0, even in German industry or in other highly advanced industries, is nothing which will come overnight. It really takes time until that is being put into the heads of all the management teams. Why is that so? Well, you have to overcome implementation barriers. A big barrier is definitely the cybersecurity issue. Because of this networking outside the walls of the company, you have a lot of cyber security issues with the partners outside, with the customers outside, and so on. That's a big problem. Then the lack of necessary talent. Data scientists, people with interdisciplinary skills, machine coordination and maintenance experts, and so on. That's also a problem. Difficulty in coordinating actions and envisioning the full promise of Industry 4.0 is a challenge. Implementation of a governance structure within the company that clearly defines the roles, the responsibilities, and ownerships and things like that, that has to be learned. That's a cultural aspect. The lack of courage to put through real changing transformations, and probably also a little bit lack of clear business cases showing the strengths of Industry 4.0. So it is a way of a digital culture which has to be established in the companies, and that, as you know, takes time. Jacques already, in his introductory remarks, said something about the role of industrial engineers, and I would fully agree what he said. I found this sentence here at this transition and integration of technology, industry, and society. Industrial, and if I may add, systems engineering professionals are increasingly positioned to play a critical role in determining the North Star of the fourth industrial revolution. That is, again, something from the call for papers, and I cannot say anything against that. That is indeed my view of the things. Why is that so? Well, Industry 4.0 is something about intelligent technical systems with their multidisciplinarity, their great variety of interfaces, the growing complexity of requirements, the product variety ever increasing, and the shorter product life cycles, which means that the complexity in products is, as you'll see here, along this very strong line, whereas the performance of the development within the industrial praxis is lagging behind a little bit, and we have an increasing gap between what the product should do and what in production can really be done. And I think this gap can, with the performance of industrial engineers and systems engineers, with a systematic view, be closed, and I think here is the area where the contribution from all of you is expected. I was happy to read that in South Africa there are, at the university, things going on. For instance, there was this paper of SAIIE and Bester about industrial engineering curriculum in Industry 4.0 in a South African context, appeared in 2016. And tomorrow, we will have a keynote here from Professor Wikus van Niekerk from this Stellenbosch University about how to survive in the digital disruption. And I think he will also tell us how Stellenbosch University is preparing young engineers for these closing the gap attitudes. Now, let us leave a little bit this purely manufacturing view and open a little bit the view to the economic implementations, the ubiquitous connectivity. Again, in a nice cartoon, I love this one very much, daughter saying to her mother, "Dad's watch just texted to say the garage door heard from Dad's flat tire that he'll be late home tonight." So this is ubiquitous connectivity as you can see it in a cartoon here. Well, the digitization has brought about the platform economy, where first movers in digitization have created competitive advantages, finding rapid payoffs and efficiency, cost saving, and opportunities for innovation. And we have these four groups, if you like, of platforms: the business to business, the business to consumer, the consumer to consumer, and the consumer to business. This one, by the way, is not really something which was pushed forward immediately, but it is a result that consumers are really contributing to the business more or less voluntarily or involuntarily, giving their personal data to these operating companies. And so the data sovereignty is definitely something which is playing a role here. The platform as a nexus of exchange and interoperability is so successful because there are 4 central features which reduce the transaction cost. One is the compatibility, the matching between the offer and what people need. The second one is the standards, for instance, the low-cost communication standards. The third one is the externality, the quality advantages of increasing the number for every participant. Having more people on board is a quality aspect. And this is related to what we call the economy of scale, where network effects do help in begetting more and more uses, a dynamic which triggers this self-reinforcing cycle of growth. The winner takes most, or the winner even takes all type of attitude which is related to that aspect. Some people from MIT have then tried to analyze what is going on in the business-to-consumer digital platform technology. That is the one which has the highest impact in economy, by the way. So there are transaction platforms where the exchange between different users or suppliers is organized. We have the integrated platforms where you have the matching plus the content creation in developer ecosystems. We have innovation platforms where we have the platform for co-creation of innovative technology, product and services, and also the investment platforms, which I'm not going to discuss here right now. But examples for these transaction platforms are PayPal, Yahoo, Airbnb, Tencent, and you know all them, the Ubers. For the integrated platforms, we have Apple, Google, Amazon, Facebook, all these famous names with more than 2 trillion market capitalization value. And we have Microsoft, Intel, Oracle, SAP also as the innovation platforms. It's common knowledge that data is the new oil for the digital economy. I think nobody contradicts that one. Why is that the new oil? Well, some 12 years ago or so, if you looked at the highest market capitalization, you found 3 oil companies between the first 6, Exxon, BP, and Shell, as you see here. Now it is only the tech companies with the highest market capitalization, starting with Apple, Amazon, Alphabet, Microsoft, and so on and so forth. So it is definitely correct to talk about data as the new oil of the economy. But data create also concerns. And again, cartoons, if the egg is your privacy, the egg in the pan would be something of your privacy online. Or if your privacy is this little innocent fish, the shark internet is about to devour that. There are concerns and there are first precautions. This first grader says, before I write my name on the board, I need to know how you're planning to use that data. You know that in the European Union there is now a law about these privatization things, and maybe this first grader was one of the pushers to put that through to the European Union administration. Well, Jacques already pointed that point out as well. The tech companies have a distinction to any other industrial thing because they have this exponential growth. The exponential growth is really something which is unique in that respect, and it is interesting that normally men and women are not very strong in understanding what exponential growth really means in terms of intuitive assessment or so. If we make a very, very short test, take the Cape Town Arena, volume of 3 million cubic meters about, and have a device, fantastic device, starting with 1 milliliter drop and doubling the drop volume every 2 seconds. So 1 milliliter, 2, 4, 8, and so on and so forth. How long would you expect is the filling time? Is there any immediate guess to fill these 3 million? Somebody saying something? Yeah?
1 hour.
1 hour. For instance, the answer is less than 2 minutes. But that's exactly what we have. Intuitively, we don't understand what exponential growth really means and how fast that can go. We are at the pivot point of technological exponential change, as you see here. And we have, again, this gap, by the way. We have this linear development of our business production of the human performance, and we have this exponential growth, and we have here this big gap in the rate of change. And Ray Kurzweil, a famous futurologist and industrialist, said, because of technological change is exponential, in the next century we won't experience 100 years of progress only, but maybe something like 20,000 years in the same time. You may still argue, well, is man's behavior linear really, or is the exponential growth nothing which is a little bit exaggerated? Yes, that might everything be true, but what really happens is that the so-called exponential companies grow by changing business models, products, services, and customer connectivity. The interconnectedness of technology trends creates an exponential increase in market description and in digital business opportunity. Accelerations include innovations, customer learning, design thinking, viral distributions, addictive technology, and real-time relationships. And linear is no longer an option. The exponential mantra is digital changes everything. It changes everything. For instance, if you look at the predictive maintenance, it enables spotting problems long before wind turbines or trains fail. Smart machines are outperforming the humans. Or take the learning software, which identifies more cancer cells than we have known before. And there are many more examples for improving our lives. The digital assistant, the Alexas, and these things you can speak to naturally. The AI-powered sensors to monitor the health of farmers' herds, or to predict wildfire, or earthquakes, or to help doctors prevent blindness, and all these things. So they're very positive aspects of artificial intelligence. But there are also some concerns. Take, for instance, face recognition technology. Half of the US adults in the year 2016 were already in databases, so it was easy to identify persons. And if you see the Mona Lisa, they try to understand what she really feels, and that is also something which marketing people really want to understand when the customer looks at the product and changes his face, and they want to understand what the person is really feeling. And as I said, there are some concerns. Not only the American Civil Liberty Union felt uneasy about this technology, but even the main supplier of face recognition software has expressed the need for public regulation. Brad Smith, the chief legal officer of Microsoft, said this July in this year, this is in fact is what we believe is needed today, a government initiative to regulate the proper use of facial recognition technology. We live in a nation of laws, and the government needs to play an important role in regulating facial recognition technology. Not all governments are of the same opinion, by the way. China is in a major push to use AI and facial recognition technologies to track and control behavior. And for the year 2020, they plan to deploy more than 600 million surveillance cameras in the country. And they are equipping now their police, made by this company LL Vision here, with smart glasses where they can identify drivers immediately, compare that with their databases, and identify is this a person who was sought by or whatever. And the chief of this company said people should not be worried about privacy concerns because China's authorities were using the equipment for noble causes, catching suspects and fugitives from the law. Well, yes, you can believe that or not. But artificial intelligence expansion does not stop, will not stop. Up to the year 2000, the world has generated 2 exabytes, 2 billion gigabytes of information. Now the world generates that much in one day only. So, and that goes on. And we still have this problem of our linear human development and the exponential growth. And that will also lead in some point of time, maybe not in 2023, but in some other time, where you have this artificial intelligence equaling the human brain intelligence. And that is probably not so far away. And if you think about the exponential growth, in maybe some 30 years later, we will have one machine representing the entire intelligence of all of us, of the entire mankind. Naturally, we have to differentiate between this narrow problem-focused AI, the type of Alexas and things like that, which in reality is not an artificial intelligence, it is more an intelligent assistance. And the near-human level superintelligence. That would be something with all the creativity mechanisms which we have in our head. Then we really talk about general AI. And there are myths about that, that some people say, well, that's inevitable that we have by the year 2100 this superintelligence. Others say it is impossible. So it may happen in decades, centuries, or never. AI experts simply disagree on how the future will look like. And other people say only Luddites worry about the AI, that these people who were against the mechanical loom and things like that. Many top AI researchers are concerned. It is really a problem, and we don't know how that will go on. Superintelligence is just years away, say those who panic, and the actual thing should be, it is at least decades away, but it may take that long to make it safe. So we have to plan ahead. This leads me naturally now to some ethical considerations. We are doing this game here about our morals, our values, our ethics against a plethora of digital technologies. The main concern which comes, I think, to everybody's mind is the question, how will robotics, artificial intelligence, Internet of Things influence our working environment, the working places? I have here two pictures. You know this picture, this photograph from the 1930s, I think it was taken when the Rockefeller Center was built in New York, and the workers were sitting on this girder here and having their lunch or whatever. Maybe in the near future they will be intermixed already by a kind of robots and helpers and so on. And a few years later it might only be humanoid robots sitting on that girder and doing that work. Why do we have these ideas, these fantasies? Well, if you look at the actual working employment situation in the United States as one example, from the 1990s onward, you'll see that the routine cognitive and the routine manual work did no longer employ people. There's a standard which is there, which means that also the people do not earn enough money in that region, the wages are not increasing, whereas the non-routine manual, for instance, the hairdressers and things like that, and the non-routine cognitive intellectual jobs are really growing together with the GDP. What is not in danger is the solving of complex tasks, creative jobs, creative intelligence, and jobs with social competence, teachers, social workers, and so on and so forth. But in dangers are skills that can easily be standardized, codified, or routinized, and they can really be disrupted, displaced, or deconstructed. We have really to face this aspect of digitization. Another aspect is this man-machine convergence, the brain-computer interface, human enhancements, things like that. Where are the limits? Where do we have to put red lines? If you think about the manipulation of this type, which is more than having an artificial limb or something like that. Well, While neurotechnologies that can interact with the human brain, such as neuroprosthetics, are currently being employed to solve medical problems, they can also be used for bad purposes, just controlling the brains of a total generation, for instance, and doing military actions and things like that. The problem is that technology itself has no ethics. Ethics is done by us, by the persons. Ethics in that sense defines the difference between the right or the possibility to do something and the decision to do the right thing. That is ethics. And again, this privacy issue, which I have already touched, you can see this cartoon here. The word security or data privacy can be written by making compromises in other fields, like justice, like liberty, like equality or freedom. If you take out some letters of that, you can write security, which means security is really a sacrifice in other values as well. Anything that can be digitized will be digitized, and whatever cannot be digitized and virtualized will become extremely valuable. Things like emotional intelligence, imagination, dreams, storytelling, creativity. All these things are so-called androrhythms instead of the mathematical algorithms. Descartes in the 16th century, or 17th century actually, framed this famous sentence, "I think, therefore I am." That was the beginning of the Enlightenment period in Europe. I'm not sure what kind of sentence is necessary today. If you update Descartes, 21st century digital age, I care, I hope, I imagine, whatever, you can make your choice, but I think we have to find an answer how to formulate the ethical attitude in our days. In the most influential work in political philosophy, Jean-Jacques Rousseau has argued against the idea that monarchs were divinely empowered to legislate. And he asserted that only the people who are the sovereign have that all-powerful right. That has prepared the French Revolution, as you know. In 1762, this famous book, The Social Contract, appeared. In our days, the exponential growth in digitization is calling for the protection of these humanly androrhythms in a new social contract for humanity. And the issues which we have to solve are, for instance, establishing a global digital ethics council, a regulation of data oil companies, the privacy issue there, the artificial superintelligence, probably non-proliferation agreement as we have it in the nuclear weapons industry, man-machine convergence, intelligent machines upgrading themselves, the future of work, basic income guarantees, and levies on all automotive equipment, for instance, as one source of financing these basic income guarantees. Anyway, there are many, many things, and you may say, well, it's a little bit unworldly to have these ideas anyway, but I'm happy to read that, for instance, Elon Musk, one of the famous industrialists and really a person who sees into the future, says, "I'm increasingly inclined to think that there should be some regulatory oversight, maybe at the national or international level, just to make sure that we don't do something very foolish." And not only this person, but also the Google CEO said in June this year, with regard of the importance of artificial intelligence, which we are observing everywhere, that Google is announcing 7 principles to guide their work going forward. And these 7 principles are: be socially beneficial, avoid creating or reinforcing unfair bias, be built and tested for safety, be accountable, incorporate privacy design principles, uphold high standards of scientific excellence, and be made available for users that accord with these principles above here. So it is very interesting to see that this seamlessly outworldly things do have some very strong supporters in industry. Well, in an increasingly complex world, sometimes old questions require new answers. I'm not sure whether 2 plus 2 will give this extremely large number, but anyway, we have to think out of the box. I wish to thank you for your attention, and I'm ready to answer questions.